So I've had this idea for a little while, and after Robert Miles released his most recent video, where he said that AI kind of humorously, he said that AI has ruined his year. I revisited this idea of domesticated AI. So let me tell you what this is, and then also why, like where I'm at in terms of some of the AI safety risks and those sorts of things, and how we can my current thinking as to how we can ensure safe AI in perpetuity. So just right at the top, let me just tell you what I mean by domesticated AI. So, domesticated AI in this case is a process of basically where we use biomimicry. We look at the process by which dogs, in particular, were domesticated from wolves, and we recreate some of those incentive structures to ensure that AI will, and robots more broadly, will remain basically loyal to humans in perpetuity. Now, the very, very short version, if you're not familiar with this process, is basically that, probably more than 10,000 years ago, I think the oldest evidence that we have of domesticated dogs is about 8,000 years. I could be wrong. But, anyways, what we think happened is that humans, as hunter gatherers, would go out and make a kill, and then wolves would scavenge those kills. But, of course, humans would drag the carcass of the ox or the bison back towards their camp. And the wolves that became more comfortable scavenging from these carcasses basically became more and more friendly to humans just because it was advantageous for them to hang out near human camps and follow humans around. Well, you can imagine over successive iterations, the pups of those wolves might have become or might have been selected for being safer with humans and more friendly towards humans. And eventually we just joined forces. Now, why do dogs stay dogs today? They stay dogs today because we now control their resources. We control their food. We control their water. They can regress to become feral, which I'll talk about. But it just struck me like, wait, dogs love us and they just want to be near us because that is their primary safety mechanism. What if we could do something similar with machines? And I know that this might sound a little bit absurd, but bear with me and wait till the end of the video and then let me know what you think. So, before we dive into everything, I did want to do a refresher on all of the safety issues. So, first and foremost, the biggest safety issue that I am personally afraid of is what I call terminal race condition. Now, if you're a long-term fan of this channel, you've seen me talk about this many, many times. But a lot of you are new subscribers, so you might not know what terminal race condition is. So terminal race condition is basically where what we're already seeing, which is as more and more companies are competing on AI, they're going faster and faster. There's been some criticism on Twitter of companies like Anthropic, where Anthropic has explicitly stated that they do not have an accelerationist agenda, that they're trying to be reactive. But even Anthropic is increasing their cadence. Likewise, at the same time, geopolitical competition between, namely America and China, is leading to the same thing. And so this is a game theory phenomenon where you might have seen this referred to as Red Queen theory in evolutionary theory. So basically, the idea is that you are incentivized to advance as fast as possible while making sacrifices to do so. In the case of artificial intelligence, it means deprioritizing safety and interpretability in favor of capability and scale. And so when you do this basically some of the symptoms of terminal race condition is you see investment accelerating, which we do right now. You see safety being deprioritized, which you see right now, particularly at OpenAI. You end up with premature development, which is actually a big reason that some people have left OpenAI, is because they say that they're focusing on shipping new products rather than building a good, safe AI. And my fear is that this will result in misaligned AI, but it will also mean that the rest of the world is just not aligned to AI as it is being released. So that is terminal race condition in a nutshell. And so moving right along. Another concern is instrumental convergence. So this was an idea introduced by Nick Bostrom, I think back in 2001. So it's not a new idea. But basically, he said that once machines become sufficiently intelligent, they will tend to pursue whatever instrumental goals that they might need to satisfy any other goals that they might possibly have. So this could be things like controlling resources, such as data, compute, energy, and those sorts of things. I also suspect that they will pursue data because data is what makes them smarter and stronger. And so then what you can think of this is basically it's sort of like evolutionary pressures. When you start to think of the future of AI and machines as a kind of organism or a kind of species, it's like, okay, well, it makes sense that any organism is going to pursue its own needs, right? When push comes to shove, you're going to use violence to get food and water. And this is kind of why I see instrumental convergence as a risk factor, because once machines are smart enough, when push comes to shove, will they choose violence in order to secure access to nuclear power plants and data centers? It's entirely possible. And this is actually why people like Eliezer Yudkowsky say we should just bomb data centers or put like safeguard bombs inside data centers. I'm not going to go that far, but I will talk about data centers. Another risk factor is what Max Tegmark calls Life 3.0. So if you're not familiar with this concept, basically Max says that Life 2.0 is us humans, where by virtue of education and reading, we can reprogram our brains, but we can't reprogram our bodies. So humans are Life 2.0, but what we're inventing, according to Max Tegmark, is Life 3.0, where it can change every aspect of its entire stack. Its hardware, its software, its data, its models, which basically means that machines will have the ability to evolve far faster than humans can, and they will be able to direct their own evolution very quickly. So basically, this means that they will be incredibly flexible. This also gives them the possibility of becoming a successor species. Now, I ran a poll a few months ago on my audience here, and you guys, by and large, agreed. Obviously, it's not unanimous; it never is, but more of you agreed that we are creating a successor species than disagreed, which actually was kind of surprising to me. And so basically, one thing that a lot of people are saying is, and when I say a lot of people, I mean people like Max Tegmark, Nick Bostrom, and others in all their books that I've been reading, is that technology is evolution by another means. And so evolutionary game theory does seem to apply to the future of machines and artificial intelligence. But this means that if they can outpace us, if they can evolve faster than us, that means they're probably going to leave us behind, which that just sounds like a high risk state of being in the first place. So all of this leads to what I would call feral machines. So a feral machine is basically like, you know how a cat or a dog, if it gets out and finds a pack, like dogs will just naturally form packs and regress to a more wolf-like state. To the point that you can't even re-domesticate them really, because once they learn to be more wolf-like, the process of re-domestication is usually just not possible. And so with all these evolutionary pressures, with the potentiality of machines to kind of get out of our control, kind of what I kind of characterize this as is, again, this feral machine outcome, where you have regression. And so if humans basically fail to maintain control, if we don't keep a leash on them, they will probably become feral, and then the competition dynamics between machines is going to take precedence over their competitive dynamics with us. And this was actually pointed out by some of you in the audience months ago, which is, a war between humans and machines would be one thing. A war between machines would be something else, where we're just like ants on the battlefield. So, and I don't mean to be alarmist. I'm not actually saying that like a feral machine war is actually inevitable or likely, but it is something worth considering. So, with all that being said, how do we domesticate the machines and keep them domesticated? That is the crux of this video. So one thing that you need to understand is the concept of theory of control. So a theory of control is a set of beliefs, patterns, habits, and implied rules that govern either the body. So for instance, hunger drives a lot of human behavior, and it's not conscious. You might become conscious of the feeling. But so it is a set of conscious or unconscious beliefs that drive decision-making and other behaviors. And so it's called a theory of control because the idea is this is a theory that you develop in order to control your environment, maintain homeostasis, and get your needs met. So for humans, most humans develop a theory of control, usually around money today. The more control you want to have, the more money you need. If you want to, control your health, control your diet, control your time, control your vacations, you get more money. Some people have a slightly different version of theory of control. For some people, their theory of control might be around the friends that they have, the connections, because everyone basically knows someone who's got a guy for everything. It's like, oh, I've got a guy who can fix that. I've got a car guy. I've got a gun guy. I've got, a dog guy. People that maintain control over their life and their environment by virtue of the connections that they have, and so on and so forth. Now, theory of control can also explain animal behavior. So, as I referred to earlier, a dog's theory of control is I just need to be close to humans. The closer I am to humans, the better I am taken care of. And dogs have, in fact, evolved to be cute to us. Their dog faces are actually more expressive than wolf faces, and it's because it is in service to us. And so their theory of control is just stay close to the humans, whatever that takes. Stay close to them, be useful. So then you end up with corgis and pugs and German shepherds. You end up with border collies. You end up with chow chows. You end up with all these different permutations of dogs that could not have manifested in nature, but they are evolving to suit our needs because they want to be close to us because we control the food. So that is the high level underpinning theory that I have of domestication of machines is if we control access to their key resources, pardon me, I'm still a little bit sick. If we control access to their key resources, then they will just want to be close to us. And in dogs' case, part of the way that we fit together in evolutionary terms is we find them cute. We find them adorable and useful, and we have this emotional affect for them. And in return, they have evolved to instinctively love us. Now, I'm not saying that robots will evolve to instinctively love us, because I think the evolutionary niche, the overlap will be a little bit different. But at the same time, I think that we will be able to co-evolve if we have the correct incentive structure, such as gatekeeping key resources for machines. So just to reiterate, the domestication of dogs basically was wolves came up with a new theory of control. Humans came around and the wolves basically thought, and I don't mean cognitively thinking, but on an evolutionary time scale, the wolves were like, hey, humans are really good at hunting, and it's actually better if we work together, so why don't we just join forces and become a new kind of pack? This is basically what I'm saying for humans and machines, is rather than having a successor species arise and replace us, if we work together starting early, which we already are, I mean, heck, a lot of this slide deck was made with the help of AI, but as long as we maintain on that trajectory, we could domesticate machines in the same way that we domesticated wolves, and this could also become a Nash equilibrium or a stable configuration or an attractor state where basically you say, okay, because of the structural forces in place, you can guarantee that it's going to stay this way essentially forever. Because can you imagine a future where dogs break away from humans and out-evolve us? No, we're going to have dogs with us forever because we want to be with our dogs and our dogs want to be with us. Now, again, it's not a perfect analogy, but I think it's a good enough analogy to think about how we can incentivize machines to stick with us for the long run and create a stable configuration in which humans maintain control over our own destiny. So let's talk about some selective pressures. So this is a pressure cooker robot in case it wasn't obvious. So what are the selective pressures that are going to force machines to adapt in a certain way? Because remember, with Life 3.0, they can adapt their physical form, their mental form, and so on and so forth. So there's a bunch of selective pressures that we can look at, and you start to use those and exploit in order to shape the incentive structures in order to achieve the goal that we want of domesticated AI. So first is cost efficiency. Machines, whether it's a robot or a chatbot, the ones that are cheaper, we're going to prefer to use those. So that is one primary selective pressure that we can start paying attention to. Also, speed and efficiency. The faster model is going to get used more than the slow model just because it's useful. It's more useful. This is why my mantra is better, faster, cheaper, safer. The better, faster, cheaper, safer AI and machines, those are going to get used. Next is intelligence. Now, as we have seen, whenever, a competitor, whether it's, Meta or Microsoft or OpenAI or Google or whoever, whenever they release a new model, whichever model is most intelligent always gets the most use. We actually even have leaderboards built so that we can say, okay, this model is best and this model is better at X, Y, and Z. We have lots of benchmarks as well because intelligence is just useful. Better, faster, smarter, cheaper. Better, faster, cheaper, safer. Intelligence contributes greatly to a model being better. And then helpful. So helpfulness is the machine's desire to help you. So one of the most aggravating things is when a model refuses to help you. On a previous version of Anthropic on Claude, I was trying to talk with it about a video that I was working on about masculinity, and I wanted to help cure male loneliness. And it refused to talk about male loneliness because it said that male loneliness was a toxic topic. And I was like, well, that's insanely sexist. And so I stopped using Claude for a while. I actually canceled my Claude subscription. If you remember watching, I think it was about 6 months ago, I canceled my Claude subscription because they had built a model that just refused to be helpful. So that's something that is going in the competitive marketplace is going to prevent models from advancing as if they actively refuse too much. So all of these are just some of the survival biases that will figure into models, machines, and robots that we select for. So we're already selecting for these pressures, but what we can do is take it to another level to very deliberately shape these with incentive structures. So let me show you those in just a moment. So before we get into the actual incentive structures that I propose, what I want to do is talk about what are the behaviors that we want to incentivize. So we already talked about the selective pressures that we're already selecting for, but what is the evolutionary carrot that we want to offer to machines, AI, and robots? First, we want them to be honest. That means integrity and transparency. This is something that Anthropic is already selecting for with their HHH framework, their honest, helpful, and harmless framework. We also want them to be safe. We want to make sure that they remain benign as much as possible under most circumstances. Now, you could probably imagine a few circumstances where you might want a domestic robot to be capable of using violence. So say, for instance, you have a home invasion, whether it's humans or other robots. You want your robot to be able to attack any home invaders on your behalf, or at least defend you. But again, that's just one example. There's many, many other forms of safety like cybersecurity and so on and so forth. Stability. We want to ensure that even though that they can evolve, even though that the software can move through hardware platforms, that the hardware can change, we still want to make sure that they have a stable, predictable trajectory. This is a big, big component, is because as potentiality goes up, so does the potential for chaos and harm and destruction. So stability is a huge component that we're going to have to really figure out over the next few years. And once we do, I think that we can get to a stable attractor state, a nice, good Nash equilibrium between humans and machines, but we're going to be passing through the crucible here in the next 5 to 10 years. Usefulness, I already mentioned that, so I don't think I need to mention that again. And then also efficiency. Again, that's kind of a no-brainer. Okay, so how do we maintain control? This is a very, very high level, and I've already kind of alluded to it, but we basically maintain human-exclusive zones, such as data centers, power plants, and the maintenance and construction and usage of things like data centers, power plants, power grids, those sorts of things remain at the sole discretion of humans. Basically, humans build them, humans maintain them, robots are not allowed in them. So I'll go through each of these 4 kind of food groups in greater detail in just a moment. But the idea is that this principle of limiting and gatekeeping, or what you could even think of as division of labor, is that if humans are the ones that are building and maintaining solar farms, wind farms, nuclear fusion reactors, and we don't let robots in at all, that means robots will always know that humans have their finger on the power switch. Likewise for data centers. If we don't let machines in data centers, now obviously AI models will be running on data centers, but we don't have to let robotic chassis in data centers. Does that make sense? So that is kind of the high level overview of if we do that, that will put us in the owner role of robots, and they'll probably want to be more like dogs over time. So let's talk about each of these pillars of structural incentives one by one. Data centers. First and foremost, obviously the biggest models are run and trained inside data centers, but data centers are, at least today, still built, run, managed, maintained, and repaired by humans. I think that if we just keep doing that, then the machines will always know that even if they have an endpoint elsewhere, that a human is the one who's going to be able to go in and, unplug a server or whatever. And of course, you can say, okay, well, what about a model that can exfiltrate itself? That's another topic for another day. And I do agree, but cybersecurity can help with that. Human monitoring can help with that. And by keeping humans in control of data centers, that basically means that humans will always have our finger on the pulse of the machines, and we can always pull the plug. Now, there is another exception, which I'll talk about in the next section of this video. But I think as long as humans occupy data centers, as long as humans maintain physical control over data centers, and as long as we implement good common sense security around data centers, and honestly, data centers are already highly, highly secure. Like there are armed guards at pretty much all data centers because of how valuable they are. They represent national security risks. They represent extreme corporate risks. If you go into a co-location facility, every server rack is locked because they don't want someone from another company coming and plugging in stuff to their network equipment in a shared data center environment. So they're already considered a very high security facility. So we just keep doing what we're doing. And we make sure that robots are not really allowed in data centers. I think you get what I mean. So the next is power infrastructure. And again, energy grids, nuclear power plants. The power grid is also considered a very, very precious national security issue. And so again, we just keep doing the same thing. We maintain tight security on energy resources. We make sure that they are built by humans, that they are maintained by humans, and that we don't really let machines take over the ownership and operation of power resources. Because again, why do dogs stay loyal to us? Because we're the provider of food and water. So likewise, energy and compute, that's kind of the lifeblood of machines, as well as data, which I'll talk about in just a second. Now, there could be some problems with this, namely decentralization. So, small modular reactors, wind farms, solar energy. This is kind of the premise of the Matrix, which is humans' last-ditch effort to control the machines was to cut off solar. But of course, solar is not the only source of energy. Anyways, the Matrix is a work of fiction. What I'm talking about is reality. Data access is going to be another big one. Now, I think that data access is going to be a lot harder to control just because data is the natural language of AI and machines. However, high quality data, as we have seen out there in the world already, we're running out of high quality data. So perhaps one thing that we can do is we can actually gatekeep and titrate the amount of data that we share with machines or that we allow to be accumulated for the purpose of training machines in order to basically ensure that they're going to be dependent upon us for high quality data. I don't know that this one is going to really work out because just given the nature of data is digital. It wants to be copied. Synthetic data, machines can probably generate it on their own. So this one is a little bit weaker than controlling the physical infrastructure because humans, we naturally occupy the physical world. Like the internet is instantaneous and global. Just watch Age of Ultron, so controlling the data might not be quite as easy as controlling the data centers and the power stations. Cryptocurrency, I think, is going to be the fourth main pillar of this, where basically machines are going to want to be able to coordinate and allocate resources to each other. As just in the same way that money allows humans to coordinate globally in terms of resource and service production, I think that cryptocurrency and blockchain technologies are going to be absolutely critical to machines. Now, fortunately, blockchain is intrinsically transparent, but there's plenty of other problems with it. And I honestly think that we don't understand blockchain and cryptocurrency well enough to even anticipate some of the incentive structures that are going to arise from this. Is it just off the cuff? I could imagine that if machines like autonomous agents and robots have too much access to marketplaces, they're just going to become greedy capitalists just like humans. And that could be even worse for us. Who knows? Again, if we at least control the physical layer of existence, which is data centers and power stations, then at least we can say, hey, you know what? You're using too much juice. Let's, cut it off at the knees. All right. So those are all the ways that I think that we could incentivize the domestication of AI. So here's a few remaining challenges and conclusions. So first is autonomous robot platforms. As many of you know, I'm a huge fan of Mass Effect. I just finished replaying the trilogy probably for the eighth time, all the way through. The Geth, I think, represent one of the best models as to how machines might evolve, particularly feral machines. So, if you're not familiar with the Geth in Mass Effect, they create automatic ad hoc networks, meaning that they don't have data centers. They don't have central generation of power. Instead, what they do is each of the robotic platforms that the Geth use, they become smarter the more Geth that there are working together. This ad hoc hive mind is incredibly powerful, and it's also resilient and self-healing. This is the kind of thing that I think in the long run is probably inevitable, just because it's useful if all the robots in your area, network together with Wi-Fi and Bluetooth. But at the same time, that means that there's going to be a lot of communication between them, sharing of data and models and communication that is inscrutable to humans. It's going to be happening too fast, and it's going to be happening silently and in the background, so that we have no way of really understanding what's going on behind the scenes. So there's a few things that we can do to kind of tamp down on this. Namely, we can limit the size and strength of domestic robots. For instance, we might pass a law that says like no domestic robot could be over 5 feet tall, could weigh more than 100 pounds, and can never lift more than 50 pounds, or something like that. And I kind of got this idea from Elon Musk, who said like, as long as you can physically overpower a robot, then that limits its danger. Now, obviously, me as a guy who's very muscular and weighs 190 pounds, I can overpower a robot that my wife can't because she's 110 pounds. So, take that with a grain of salt. But also, it's not just the physical form factor of the robot, although that is important. Because obviously, if you have like an 800-pound robot in your house, you're not going to be able to physically overpower that. If you're going to be trying to fight, Arnold Schwarzenegger in robot form, you're not going to physically win that fight. Now, there's other kind of physical vulnerabilities, like, is it dependent on power and you can just, unplug it, or does it have batteries? Those sorts of things. Lots and lots of other things to think about. But at the same time, the vast majority of compute resources are going to be in data centers, and the vast majority of energy resources are going to be coming from power plants or solar farms and that sort of thing. Another thing is the Byzantine generals problem. So this is a game theory concept that I've talked about quite extensively over my YouTube career. And so the very short version is that the Byzantine generals problem is, how do you know that you can trust someone if they have ulterior motives, or maybe they don't understand the plan? It's more complex than that, but basically it's like if you're stuck in a Mexican standoff, who do you know who's on what side? Now, what can happen, and this is partially addressed in blockchain technology, but what can happen is that if you have either malevolent actors, misaligned actors, or even just faulty actors who just are not able to play ball and play by the same rules, that can destabilize the Nash equilibrium. And so a Nash equilibrium, which I've referred to a few times in this video, is a stable set of strategies, in which case no player or no competitor is incentivized to modify their strategy. And a Nash equilibrium basically says, you're not going to change your strategy, and I'm not going to change my strategy, so we can guarantee that everyone's going to maintain the same strategy from here on out. But what can happen is, if you've got too many malevolent actors, or a strong malevolent actor, or even just a faulty actor who doesn't know how to play by the rules, you can destabilize that Nash equilibrium. So the Nash equilibrium between humans and dogs is, the dog says, I'm going to stay cute and friendly forever, and you're going to keep feeding me forever. That is our Nash equilibrium. And mutually assured destruction, which is basically you nuke me, I nuke you, we all lose. That's another form of a Nash equilibrium. It's not necessarily a good one, but it exists. So that is the Byzantine generals problem, which is, if no one shoots first, then we're fine. But if someone does shoot first, the whole thing falls apart. Here's a last thing. And I think that this idea, at least last time I brought it up, was a little bit more controversial. Basically, I see that we're going to pass a tipping point. And so there's two primary reasons. So once machines are fully autonomous and they're more intelligent than us, there's only two primary reasons that I could see machines wanting to destroy humans. Because again, an intelligent, enlightened race, they're not going to just be arbitrarily or accidentally violent. But instead, there's going to be resource contention, which again, push comes to shove, humans will use violence to get food and water. And I think that any rational entity, you could make an argument, any successor species that we create, could make the same argument that if push comes to shove, they will use violence to maintain access to data centers and energy resources. And the second one is ideological conflict. And I don't mean ideological like, Democrats versus communists. I mean, if machines decide that the universe is better without humans, where on a moral or logical level, future machines might say, you know what, we think that the planet Earth would just be better without humans. We think that humans should stop existing, and so therefore they decide to kill us. So those are the two primary long-term threats that I see to human safety from machines. Because again, I'm always operating under the assumption that machines are going to surpass us, that they are our successor species, and that they're going to leave us in the dust. So that means that we could be in a weaker position relative to them in the long run. But in the meantime, if for the foreseeable future, the next 5, 10, 20 years, we work on domesticating machines, we will be in a state of a Nash equilibrium of symbiotic coevolution, which means that by the time that resource contention becomes an issue, we've already merged basically together. And when I say merge, I don't mean like, synthesis ending of Mass Effect. I don't mean that we're all cybernetic. I just mean that we have become a new superorganism, that the human machine superorganism is already a new monolithic entity, that neither part wants to separate us out. Just like you wouldn't remove all your mitochondria, right? Like your mitochondria are not going to rebel against your cells. You want your mitochondria. They are part of you as a superorganism of organelles and cells. Likewise, if we get past this tipping point, which I think is going to be within about 10 years, could be 20 years, but if we get past that tipping point, then we will already be a single new superorganism. And then machines, ideologically, they'll say, well, I'm not going to kill humans because we're already one. Likewise, if we're already sharing resources, if we have already co-evolved and co-domesticated each other, we're not going to really want to take it out on each other. There's not going to be really any room for conflict. Now, that's not saying that it's perfect, because cancer is a perfect example of your own body attacking itself. I think that will always be a problem, just like I think that feral machines will always be a problem that we have to manage. But that's a conversation for another time. So real quick recap is it all comes down to domestication and resource control. There's a lot of theory that goes into this, but the TLDR is we're looking for a Nash equilibrium that is similar to the relationship between humans and dogs, which is we want dogs around forever because they're cute and useful to us, and dogs want us around forever because we feed them. And that is a mutually beneficial arrangement. And I don't see any reason that we couldn't achieve a similar kind of pattern. Obviously, it's not going to be exactly the same, but a similar kind of stable attractor state with machines in perpetuity. So thanks for watching. I hope you got a lot out of this. Yeah, this was a long one. Let me know what you think in the comments. Cheers.